Wastewater Math Quiz number 4. For this math quiz, you'll need a calculator and your formula sheet. As always, I do not own these questions. They were sourced off the open internet, and this video is for learning and educational purposes. Hopefully it helps you. Let's get into the questions. Question 1. MLSS is pumped to an anaerobic digester. The MLSS is 3,000 milligrams per liter and contains 80% volatile solids. The digester contains 1.82% total solids. Biosolids removed from the digester are only 67% volatile. What was the percent volatile solids reduction through the digester? A. 47.8%, B. 50.5%, C. 48.3%, or D. 49.2%. Question 2. A belt filter press receives a feed at 3% total solids and produces a cake that is 20% total solids. If the influent rate is 50 gallons per minute, what will be the volume of cake produced in an 8-hour run? A. 17.8 cubic yards, B. 16.5 cubic yards, C. 18.3 cubic yards, or D. 19 cubic yards. Question 3. A trickling filter has a diameter of 179.9 feet. If the flow through the filter is 2.74 million gallons a day and the recirculation rate is 24% of the flow rate, what is the hydraulic loading rate on the trickling filter in gallons per day per square foot? 120 gallons per day per square foot, 145 gallons per day per square foot, 134 gallons per day per square foot, or 158 gallons per day per square foot. Question 4. What is the solids loading rate on a secondary clarifier with a diameter of 59.8 feet if the flow rate is 946,000 gallons per day with a mixed liquor suspended solids of 3,178 milligrams per liter? Is it A, 7.8 pounds per day per square foot, B, 8.93 pounds per day per square foot, C, 9.42 pounds per day per square foot, or D, 8.37 pounds per day per square foot? Question 5. Determine the feed rate of dry alum in pounds per day if the drawdown in exactly 5 minutes was 89.4 grams and the flow was 1,679,000 gallons per day. Is it A, 52.4 pounds per day of alum, B, 59.1 pounds per day of alum, C, 56.7 pounds per day of alum, or D, 61.3 pounds per day of alum? And the answers are question 1, D, question 2, A, question 3, C, question 4, B, question 5, C. All right, now let's solve these questions step by step. Question 1. MLSS is pumped to an anaerobic digester. The MLSS is 3,000 milligrams per liter and contains 80% volatile solids. The digester contains 1.82% total solids. Biosolids removed from the digester are only 67% volatile. What was the percent volatile solids reduction through the digester? First, let's pull out the known and unknowns. So what we know is the MLSS was 3,000 milligrams per liter. The MLSS volatile solids was 80%. The digester was 1.82% solids. And we removed 67% volatile solids. What we don't know is the percent volatile solids removed. Well, guess what? We have a formula for that. Volatile solids reduction is equal to what goes in minus what goes out divided by what goes in minus what goes in times what goes out. And then we're going to multiply that by 100%. All right, so we need to convert our percentages into decimals, and it was the 0.8 minus 0.67 divided by 0.8 minus 0.8 times 0.67 times 100%. So let's solve our brackets first. So on the top you get 0.13, and on the bottom we got 0.536. So now we're going to subtract the 0.8, so minus 0.536, and you get 0.264. So now we can do division, so 0.13 divided by 0.264, and you get 0.492. We can multiply that by 100%, and the answer is D, 49.2. Question 2. A belt filter press receives a feed at 3% total solids and produces a cake that is 20% total solids. If the influent rate is 50 gallons per minute, what will be the volume of cake produced in an 8-hour run? Let's pull our known and unknowns out of this question. So what you know is the feed was 3%, the cake produced was 20%, the influent flow was 50 gallons per minute, and we're looking for a time of 8-hour run, and we want to find the volume of cake. So dilution, or two normal equations. So C1 times V1 is equal to C2 times V2, where C is concentration and V is volume. So first, let's get our 50 gallons per minute into 8 hours. So 50 gallons over 1 minute. There's 60 minutes in an hour. The minutes cancel out, and we do 8 hours. So we get 24,000 gallons in 8 hours. So we can plug that into what we have. So we had the feed of 0.03 times the flow of 24,000 gallons, and it's equal to the cake of 0.2, and we need to find the volume of the cake. To do that, we're going to divide the 0.2 out so we get it on one side of the equation. So we have 0.03 times 24,000 gallons divided by 0.2. Solve for the top first. So we're going to multiply the 0.03 and 24,000 gallons together, and you get 720. So we're going to divide that by 0.2. And we do that division, you get 3,600 gallons, but we're looking for the answer to be in cubic yards. So we do convert. We get 3,600 gallons. There is 7.48 gallons in a cubic foot and 27 cubic feet in a cubic yard. We're going to set this up so it cancels. So 3,600 gallons times 1 cubic foot over 7.48, the gallons cancel. And 1 cubic yard over 27 cubic feet, so the cubic feet cancel. So it's 3,600 divided by 7.48 divided by 27. And the answer you get when you do all that division is 17.82, or A, 17.8 cubic yards. Question 3. A trickling filter has a diameter of 179.9 feet. If the flow through the filter is 2.74 mgd and the recirculation rate is 24% of the flow rate, what is the hydraulic loading rate on a trickling filter in gallons per day per square foot? So pull your known and unknown out of your question. So what you know is a diameter of 179.9 feet, a flow of 2.74 million gallons a day, a recirc rate of 24%. We're looking for the hydraulic loading. The formula for hydraulic surface loading, gallons per day per square foot, is equal to the flow rate, gallons per day, divided by the surface area, square feet. Well, first we need to find the flow. So we had 2.74 million gallons, and we're going to have to add that to the recirculation rate, which was at 24%. So 2.74 times 24% is a decimal, 0.24. And then we're going to multiply that by a million to get rid of the million gallons a day and get into gallons. So when we do the 2.74 times 0.24, you get 0.6576. We're going to add that to 2.74. You get 3.3976. We're going to time this by a million to get into million gallons, so gallons per day. You end up with 3,397,600. So we can plug that into our formula. Now we need to find the surface area of our trickling filter. They gave us diameter, so the area is 0.785 times diameter squared. So 0.785 times 179.9 times itself. Do your math. You get 25,405.75 square feet. So now we can plug that into our formula. So we have the 3,397,600 gallons per day divided by 25,405.75 square feet. So you do division, and your answer is 133.73 gallons per day per square foot, and your closest is going to be the answer C, 134. Question 4. What is the solids loading rate on a secondary clarifier with a diameter of 59.8 feet if the flow rate is 946,000 gallons per day with a mixed liquor suspended solids of 3,178 milligrams per liter? Start by pulling your known and unknowns out. So what you know is a diameter of 59.8 feet, a flow of 946,000 gallons per day. The MLSS is 3,178 milligrams per liter, and we're looking for the solids loading rate. The formula for solids loading rate, pounds per day per square foot, is solids applied, pounds per day, divided by the surface area, square feet. So first, let's do a pounds formula to find our pounds per day, which is the capacity, million gallons, times the concentration, milligrams per liter, times 8.34 pounds per gallon. Well, we need to get our 946,000 into mg, so we're going to divide it by a million. You do that, you get 0.946 mg. So now we can plug that into our formula. So we have 0.946 million gallons times 3,178 milligrams per liter times the standard of 8.34 pounds per gallon, multiply across, and the answer was 25,073. So now we can plug it into our formula. All right, so now we need to solve for the surface area. They gave us the diameter, so 0.785 times diameter squared. So we have 0.785 times 59.8 foot times itself. You do your multiplication, you end up with 2,807.2 square feet. We can plug that into our formula. So we have 25,000 pounds per day divided by 2,807.2 square feet. So when you do your division, I get 8.906. So my rounding was different in the problem, so the closest answer is going to be 8.93 pounds per day per square foot. And you'll notice that with these problems, if you round different than they do, your answer will be slightly off. Question 5. Determine the feed rate of dry alum in pounds per day if the drawdown in exactly 5 minutes was 89.4 grams and the flow was 1,679,000 gallons per day. Well, let's pull our known and unknowns out of our problem. What you know is a drawdown of 5 minutes. You drew down 89.4 grams. The flow is 1,679,000 gallons per day. And what we're looking for is how many pounds per day. So first, I'm going to get this into a number I can manage. So I'm going to get the 84.9 grams. We're going to divide that by the 5 minutes so we can get the drawdown by the minute. When you do that division, you get 17.88 grams a minute. Now we're looking for pounds per day, so we're going to do some converting. So we have 17.88 grams per minute. We want the minutes to go away, so we're going to multiply that by 1,440 minutes in a day. So the minutes will cancel out. And there are 454 grams in a pound, so the grams are going on the bottom, so they cancel out. So what we're going to do is 17.88 grams per minute times 1,440 minutes in a day divided by 454 grams in a pound. Your grams cancel out. We're left with pounds per day. So you do your math. And the answer is 56.71. So your closest answer is C, 56.7. And there we have it. Another quick 5 quiz questions worked through step by step. Hope this helps you learn and study. Thanks.